We're looking at the sample exam chapter 3, and if you recall, in chapter 3 that was probability. It's the probability unit. And we looked at odds and probability. We also looked at using counting methods to determine probability, the counting methods from chapter 2. We looked at mutually exclusive and non-mutually exclusive events. And non-mutually exclusive. We looked at independent and dependent events, And of course, with that comes conditional probability. So let's have a look. A soccer player has 17 attempts on net and 6 goals scored. So this is the total attempts, and they scored 6 out of 17. What are the odds in favor of her scoring the next goal? So we have the probability of getting a goal is 6 over 17. So the probability of not getting a goal, or the complement, would be 11 over 17. So the odds in favor would be 6 to 11. Of course, C would be the odds against. A committee of 3 people will be randomly chosen from a group of 9. 5 females and 4 males, which represents the probability of selecting a committee of at least 1 male and at least 1 female. Now this is probability using counting methods. Probability using counting methods. And that was in section 3.3. Sorry. And so we have here the total. If there's 9 people, 9 choose, and there's 3 people on the committee, 9 choose 3 is the total. So we have C and D is gone. And of course, probability is always written over the total. We have some cases here. We could have at least 1 male and at least 1 female. So of 3 people on the committee, if we have 2 males, that would leave us with 1 female, still satisfying the condition of at least 1 male and 1 female. Or we could have 1 male and 2 females, and that also will satisfy the condition of at least 1 male, at least 1 female. If we decided on choosing, say, 3 males and 0 females, well here, that doesn't satisfy the condition of at least 1 female member. So that's no good. So here if we have 2 males and there are 4 males to choose from, this would be 4 choose 2, and 1 female, which is 5 choose 1. Or, and of course we use plus, 1 male would be out of 4 males, 4 choose 1 times, and there's 5 females to choose from, and they're going to fill 2 spots, 2 places. So let's look, if we look at A. In A we have 4 choose 1, which is 4 choose 1 times 5 choose 2. 5 choose 2, yes. We have 4 choose 2, 4 choose 2, and 5 choose 1. So we have, the answer is A. A and B are mutually exclusive events, and that's a very important statement. The probability that either A or B will occur is the probability of A union B, and that would be 56%. If the probability of A occurring, that's P of A, is 17%, what is the probability of B not occurring? And so we can draw a Venn diagram of the mutually exclusive events, A and B. Mutually exclusive, there will be no overlapping region. There's nothing in the intersect. And so if we have 56% in A union B, then that means 44% is on the outside. So now if 17% are over here, we need to know what is not in D. So he needs to know what's not in here. Not in here. What's not in here would be in what's in A and what's in outside of A and B. And that would give us 17 plus 44, which would give us 61%. So mutually exclusive was a very important point in this section, in that we had to know that A and B, there was no 0 in the intersect. You have a 6-sided die with each side numbered 1 through 6. You also have a coin with heads on one side and tails on the other. What is the probability of rolling a number greater than 4 with the die and tossing the heads with the coins? These are independent events. They're independent, as tossing the coin does not affect the outcome of the die. So we have on the die we have 1, 2, 3, 4, 5, and 6. And we can have 2 options for each one here. We can roll a heads or a tails for each one. And we can see here now that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total possible outcomes. So our total probability is always over the total possible outcomes. We want a number greater than 4 and heads. So greater than 4, 4 is no good. We only want this way. So we have 5 and heads and a 6 and heads, and that will give us 2 outcomes, which when we reduce the fraction will be 1/6. Which would be, so that's independent events. A deck of 40 cards consists of 4 different colored sets: red, blue, green, and yellow. Each set is numbered from 0 to 9, as shown. That means there will be 10 cards in each one. There's 10 cards here, 10, 10, and 10 give us 40 cards in total. If 2 cards are randomly picked from the deck, what is the probability that the first card is blue or green and the second card is also blue or green? So here we have dependent events. The first card, we have to pick a blue or a green, which there are 10 blue and 10 green in the pack. That would give us 20 cards to choose from, or that we want, over the 40 that's total. Multiply by, because we want a blue or a green and a blue or a green. Now what's left in the deck, let's assume we picked one of those 20 cards. We must assume that we picked one of the 20 cards. And so now there is only 19 left in the deck. Now there will only be 19 left in the deck. So it's going to be 19 cards over, and there's only 39 cards left. This will give us, when we multiply, of course, this is actually 1/2 times 19 over 39. This will give us 19 over 78, which would be C. A 5-digit number is generated at random from the digits 2, 3, 4, 5, and 8 with no repetition. What is the probability? It will be an odd number. So now probability, once again, we have to figure out first what the total would be. 2, 3, 4, 5 digits. There is, in the first position, there's an option of 5. In the second, there's 4, 3, 2, 1. That is, we have 5 options for position 1, 4 options for position 2, 3, 2, and 1. And that would give us 120 different options for the total. That's our total. Now what we want is an odd number. In order for a number to be odd, it must end in an odd number. And so we have an even and an even and an even. So there's only 2 options for that final number to make it odd. Once we use either the the 3 or the 5 there. Once we use, let's say we use the 3 there, then we have 4 numbers left over. 3, 2, 1 to fill the other positions. This would give us a total of 48. And so the probability of an odd is going to equal the 48 over the 120, which will give us 2 over 5, or 0.4, or 40%. So don't forget, when we're talking about probability, we need to find the total first. A person will be randomly selected from a group to draw a marble from a bag. The odds of selecting a female from the group, so the odds of selecting a female from the group is 7 to 8. So that means the probability of a female will be 7 over 15. That will give us the probability of a male being 8 over 15. It also says that the odds of drawing a red marble will be, so the probability of getting a red one will be 1 over 4. And the probability of a non-red, of course that's the complement of red, is going to be 3 over 4. What is the probability of a non-red marble being drawn by a male in the group? And so we have, we want to know the probability of a male, which is 8 over 15, and non-red, which is 3 over 4. And this would give us 2 over 5, which equals 40% again. So we have that multiple choice number 11 to 15 on the public exam is the probability questions from the probability chapter. Our constructed response questions from chapter 3 will be number 53, and you can expect it to have A and a B section, maybe even A, B, and C. What we didn't see on this sample is that using counting methods to determine probability, and we didn't see here the conditional probability problems. And if you look at the conditional probability problems in section probability in section 3.5, they were popular on the mid-year exam. So if you take a look at those were slightly different than the conditional probability here on the sample.